Good day. This is grade 12, exam 2019, paper 2 and question 9a. Right. So what they want is we must calculate the area of triangle FGH. So what's this? It looks like almost like a 2D or 3D dimensional. I've tried to draw it the best. You can just look in the exam paper. There you'll see question 9B, 9A. And so let's see if we can identify the triangle FGH. So there's F, there's G, sorry, there's the F, there's G, and there's H. So the blue triangle is the one that we must find the area, right? So if they want to find the area, if you go to your information sheet, so here they give you the area of a normal triangle ABC, which consists of two sides, side A and side B, and an angle C. So we already, just looking at the formula, we know we need two sides and angle. So what do we have in this FGH? So let's just look properly. So let's just focus here at the bottom. I'm going to draw this rectangle in green, if you can see it. So that's a rectangle in green. So this rectangle has got this 10 meters, and it's got 3 meters there on the left and 3 meters on the right. So because this is 3 and that is 3, if this is a rectangle, then if that is 10, then we can confidently say that is also 10. And we can only say it because of the two opposite sides that are 3 that are the same. That means automatically, if the bottom one is 10, then that is 10, right? So we already have, and 10 is the same like the blue triangle, the bottom side. So we already have, I'm going to make it blue now. We already have one, but we need either two more sides or we need an angle. Now, what do we have? Now, I'm going to focus on this part here at the bottom, FACH. And if you can see FACH, I'm going to try to draw it in red. So this FA, and it goes to C and to H. So it's that part over there. But if you look closely, you have, although you have a 7 at the bottom, the left is 3 and the right is 2. So you can't just assume that is 7. So it doesn't work the same like we did there at the bottom, because that is 3 and that is 2. I'm going to go to another page and we're going to do something with this diagram, but only focus on the red FACH. So I'm going to draw that over. So there's the FA, there's C, there's H. So it looks probably something like that. So let's just take this one out because this is a bit longer, because FA is 3. So it looks something like that. So this is F, this is A, C, H. FA is 3, A, C is 7, H is 2. So just keep in mind, it's exactly the same, the red one that they just do separately now. There's FA, which is 3, AC, which is 7, and HC, which is 2, and we need FH. Because remember, we need the blue triangle. So FH is part of the blue triangle, but also part of this red, whatever you call this diagram. Right, so we have this. So what are we going to do? So let's focus on this. We have 3 sides. We need FH. That is the focus. But like we said, we can't say that is 7. Why not? Because that 3 and that 2 is not equal to each other. So that is not going to work. So what I'm going to do now, I'm going to draw a line over here. And this line from there to there is 2, and from there to there it's 1. And this line, keep it a dotted line. Let's make it blue. So I'm gonna draw this line over there, and now we have this side of this line that is now equal to 2. So remember that we explicitly say that from there to there is 2, and that means from that point to that point will be 1, because the 2 and the 1 must equal the 3. Why did I do that? I did it because now we sit with a quad that has got 2 sides, which is 2, and we have now 2 sides here as well. So if we can find this side over here, then automatically that one will be equal to that. And now if you look carefully at the bottom, the reason we said that if we want to draw it is because now we have a triangle here at the bottom, the green. And this triangle, we drew it so that the bottom left part is 90 degrees. So if you have a triangle which is 90 degrees, then you can use the rule of Pythagoras, which say because we have the one side and another side and 90 degrees, and now we can say, so let's call this point A, let's call it B for now. So now we can say in Pythagoras, AB squared plus AC squared equals BC squared. And you see that? So we say that is AB squared plus AC squared equals BC squared. So now let's see if we can work it out. AB is 1, so that's 1 squared is just 1. AC is 7 squared, that gives C squared. So if you look carefully, then BC squared will equal 50, and then BC alone will equal square root of 50. So that's that BC over here. So now we have square root of 50. And like we said earlier, if that is square root 50, and because these two sides are the same, that FH is now square root 50. So that's what we did it there. So now we have a side. Now we can go back here and say FH is equal to square root of 50. All right, so now we have a side, we have another side. Let's see if we can find HG. Let's see if we can find HG, and I'm going to use exactly the same. Let's do yellow. And I'm going to use this yellow, let's call it quad over here. I'm going to use HCBG, and I'm going to redraw it separately. HCBG, and it looks like this. HC, that's H, that's C, that's 2 units. Let's bring that down a bit, make it taller. Why taller? Because this is G and B, that is 3 units. And I'm going to draw this like this so that this N, that is 90 degrees. And let's put in the sides. CB is 8. And so this whole angle over here, let me just show. This whole one equals 3. But we purposely drew this one so that GN equals 2 and NB equals 1. And both of them together will give us 3. And the reason why we do it is because we can use the same method as the previous question. If we can prove that, if we can get this side, then because that is both 2, then we have HG as well. Let's come back to the big picture. We want this HG over here. And now we're using the yellow quad over here just to see if we can do it. And I just redo it. There's all the sides. HG is 2, GB is 8, and GB is 3. And I just redo it over there. Exactly the same. Right. So let's see if we can find the CN over here. So CN, again with Pythagoras. So NB squared plus CB squared will equals NC squared. So that's NB squared plus CB squared equals NC squared, that's Pythagoras. NB is 1 squared plus CB, that's 8 squared. That equals NC squared. And if you do the maths, you'll get NC equals, this is 1 plus 64 is NC squared. So NC square root of 65. So this is square root of 65. And because that's square root of 65, HG will also be, square root of 65. Let's go back to the big sum, and that's the HG we just found out, which was square root of 65. So now we have that. So again, why do we want all the sides? Because we're looking at the area of the triangle. That is what we want. And we need two sides and an angle as well. So we need two sides and an angle. So let's see what we have. So we have the two sides. If at 1 square root of 50, square root of 65, and we also have another side 10 over here. So now we have three sides, but let's just look at the other formula. This is all on your information sheet. The other formula say if you have a triangle ABC, and if this is A, the ABC, the big ABC is the angles, and the small a is the side opposite the angle A. Then you have the C opposite the angle C, and the small b opposite the angle B. So now you have this triangle, and then you have this formula over here. So what can we do with that formula? So let's see, what do we have if we go back into this big sum? We have three sides, but we don't have that angle. So let's see if we can find that angle. Now the question is, why do we need the angle? So if you look at this over here, let's come back to the first equation. We have two sides, side A and side B, which in the big sum, we're going to say is square root of 50 and square root of 50 and square root of 65. But if we can get that middle angle as well, then we can use this formula to calculate the area of triangle ABC. But we don't have that angle yet, but we're going to work it out now with the second equation. So how we're going to structure this is to say, if you look at the sum again, we have the blue triangle and we need that H. And according to this formula over here, that H, which is A in here, is opposite this over here. And in our sum, that is 10 squared. So that 10 squared is this one, is this 10 over here. So I'm going to use this 10 and work out that angle over there. And just keep in mind, we have these two sides as well. So let's see what we can do. We have 10 squared equals b squared. So if you just take the sum, I'm going to use the square root of 50 squared plus square root of 65. I'm just using the other two sums, minus 2 times square root of 50. Oh, my space is running out. Let me just write it properly. So let's do it. Let's do it here. So 10 squared equals square root of 50 squared plus square root of 65 squared minus 2 times square root of 50 times square root of 65, and all of that equal to cos A. Let me just remove this. So now you have a big equation which gives you 10 squared equals, and this is just the two other sides, the square root 50 and the square root 65. I've just substituted in here, minus this 2. So this 2 and this 2 are the same. And then I just use the same two angles again, B and C. And I just said cos A. And cos A in the sum that we want to work out is not A. That's actually this over here, which is H. So let's just change that to cos H. And if we, so I just use the same h in the question. And if you do this properly, you'll get 100 equals square root of 50 squared is just 50. This is a big sum. So what I'm just going to do now, you can do it on your own. You can work it out. And if you work it out properly, you'll get the answer of h equals 82.4. So that's just previous grade's work. If you have all of that, you'll get the angle h equals 82.4. And remember, the 82.4 is now this over here. So that's 82.4. Let's just do that. Just highlight that, and that is now 82.4. So now we have the 82.4, and remember, the reason we want the 82.4 is because we want to put it now into this formula over here. Because we have the triangle ABC, we have the two sides, and now we have the other side in the middle. So now we can actually say, let's see if I can squeeze it here on top. So that is now equal to a half. We have the square root of 50. We have the square root of 65. That's the two sides, and the angle in the middle is the one we found, the 82.4, and we can put sine of 82.4, and if you work all of that out, you'll get to an answer of 28.3. What is your mean to be? Let's just look what we have. So all the sides is in meters. So all of this is square root of 50 meters, 3 meters, 10 meters, etc. So your answer will just be 28.3 meters squared. There we go. So that's the area. Let's just summarize again. Why did I do what I did? So I wanted the blue triangle. I had none of the sides. So I used first at the bottom to get to that 10 over there, and that I could do because the two sides equal to 3. But the red quad over here, I couldn't say that equals 7. I couldn't do that because we have a 3 over there and a 2 over there. So for that, and for the yellow one is the same, I just went separately and I used this method to get square root of 50. I did the same for the right hand side. I got square root of 65. That's why I ended up with that 3 sides over there. Why did I want that angle? It's because I used the formula. That's the formula of a triangle that's given on your information sheet. So we need 2 sides and an angle in the middle. So I decided let's use the 2 sides, square root 50, square root 65, and I want that angle in the middle. But to get that angle in the middle, you need 3 sides, but the angle in the middle must correspond with the opposite side here of 10. That's why I used this over here, this formula. And I just said 10 squared. And remember, if you have the formula, this one side here that you have on the left-hand side of the equal, that side must be the opposite angle there. So that's why I have a squared, which is the side, and I needed the angle A. So I had this side 10, and I needed the opposite angle to that side. So that's why I went this route. Yeah, I just substituted everything in. There's a 10, there's the H, and eventually I got to an angle of 82.4. That gave me that angle, and now I had everything to do the area of a triangle. Just substituted the 2 sides and the angle in the middle, and I got to 28.3, and the answer is in meters squared. So thank you very much. If you have any problem with this, is the way I did it, you can maybe just let me know. Then I can just explain it maybe in a different way. But the way I've explained it is the best. But if you want to talk about why I did what I did, then we can discuss that. Thank you very much. Hope you have a good day. Goodbye.